In today's lesson, I'm going to teach you how to assign redox numbers, also known as oxidation states, to elements within a compound, whether that's an ionic compound, such as a salt, sodium chloride for example, or covalent molecule like SO3, CH4, and so on. But before we get into some of the examples I have, I'm going to discuss some of these rules that are on the screen here and explain what they mean. So let's pretend we have a compound A, B. In that compound, one of the elements will have a plus oxidation state and one will have a minus oxidation state. So let's just say A is plus and B is minus. Plus means that the element has, in inverted commas, lost electrons, and minus means the element has gained electrons. Lost could be as in an ionic compound where the metal transfers an electron to a non-metal, or lost in the sense of a covalent compound where that electron is shared with the other element in order to complete the outer shell. But plus means sort of giving away an electron, and negative means gaining an electron. If you look at the first three there, we have everything in group 1 is going to have a +1 oxidation state. In other words, it needs to lose, elements in group 1 need to lose 1 electron to complete the outer shell. So take sodium. Sodium is an electronic configuration of 281. So 1 electron in the outer shell needs to be lost to complete that outer shell, and therefore has +1. Group 2 would be +2. Aluminium would be group 3, +3. Now notice group 4 is missing because group 4 could be +4 or -4, and that depends on the compound. So once you get practice at this and more experience, you will know when an element in group 4 will be plus or minus, depending on the other thing that it's bonded with. Then for group 6, it's -2, group 7 is -1, and then group 8, the noble gases, would be 0. In the case of them being as a standalone element and the fact that they have a full outer shell. Now, if we look at the other rules at the bottom there, elements such as carbon, H2, have an oxidation state of 0. They are not bonded to anything else. So they have not gained an electron or lost an electron. They're simply in the elemental state. So that's why it's 0. If a molecule is neutral, then the sum of the oxidation states must come to 0. So if you have, for example, a molecule like CO2, that molecule is neutral. It doesn't have a charge, which means the oxidation states must add to give 0. And then for the final point, similar sort of thinking, if a molecule is charged, then the sum of the oxidation states must add up to that charge. So for example, say we had SO4 2-, or maybe PO4 3- phosphate. In the case of SO4 2- sulfate, the sum of the oxidation numbers must add to -2, and then for phosphate, they must add to -3. Okay, so let's take a look at a few of these examples. And what I'm going to do is just going to pick a few at random, and then I want you to finish off the remainder yourself and check your answers against the mark scheme I have attached beneath this video. And the whole point of this is to make sure to see if you've understood it. So let's start with, say, this one. So NO2, nitrogen dioxide. We know that nitrogen is in group 5, oxygen is in group 6. From the rules at the top, you can see that oxygen is always -2 unless it's bonded to fluorine, because when it's bonded to fluorine, fluorine is more electronegative. So therefore, that would take the negative number and oxygen would be the positive number. So in this case, oxygen is more electronegative than nitrogen. So there's 2 of them. So it would be -2, -2, which means nitrogen has to be +4 for this molecule to come to 0. Remember, if a molecule is uncharged, its total would therefore be 0. which means the oxidation numbers must add to 0. Let's take a look at the next one now, which is IF7. We have fluorine and iodine are obviously both in group 7. However, fluorine is more electronegative than iodine, and the more electronegative atom gets the preference for the negative number. So that will always be the negative number. So there are 7 fluorines, so each one would be -1. Now you'll notice I'm writing this out the long way. I've not written -7, I've written 7 lots of -1, which means for iodine, to balance this, it must be therefore equal to +7. Right, let's take a look at something with a charge now. So for example, what about this one? Nitrate. So nitrogen and oxygen again, but this time we have a -1 charge. So we know oxygen has to be -2, and there's 3 of them, so -2, -2, -2, comes to -6. So for this to come to -1 overall, which is what a -1 charge is, that's just -1, that means nitrogen has to be +5, because +5 take away 6 gives -1. So I hope that's helpful. Don't forget, go ahead, finish off the remainder of these and then check your answers below the video.